Right, let's move on to the next theorem. Remember that we are proving that a line drawn from the center of a circle perpendicular to a chord bisects the chord. What is it that, remember this was not there originally. We are saying here, if this side is the same as this one, therefore what is this point called? It is called the midpoint. So there's a line that is drawn from the center of a circle to the midpoint of a chord is perpendicular to a chord. We want to prove that this angle there, it is 90 degrees. That's what we want to prove. We want to show that this angle here is 90 degrees. That's what we want to prove. You do the same thing. In other words, your grade 10 part on learning about congruency become very important. These are the 4 cases of congruency. Then you've got to apply one of those to show here. In other words, we've got to have, what is it that we want to, let's have our construction. What is a construction? Construction is something that has not been given into the diagram where you go and put it in. How do you see that there is a construction in this diagram? Whatever has been put on has been drawn on dotted lines, it will always be a construction. Now you do the same thing as you've been doing this side. You construct this. This is a radius. This is another radius. Now if I'm going to compare these 2 triangles, this radius will be the same as this radius. That becomes important. This part, let's call the center as O. Let's simply call it the same way as we call it that part. This is A, this is N, this is M. That is M. Remember, what is it that we are required to prove here? We are required to prove that RTP. What is it that we want to prove? We want to prove that this angle is 90 degrees, or this angle is 90 degrees, any of the 2. It can either be M1 or M2. We want to prove that M1 or M2 is equal to 90 degrees. So let's just pick one. We want to prove that angle OMA. We want to prove that OMA is equal to, let's just call it M1 to make life easier for us. Let's just call it, we want to prove that M1 is equal to 90 degrees. That is what we want to prove. Remember this side, we were given 90 degrees. We wanted to prove that these 2 sides are the same. In this case, we're given that these 2 sides are the same. We want to prove that either of these angles are 90 degrees. Remember, when I add them, I will get 180 degrees, 90 and 90. We want to prove that one of those angles is 90 degrees. Construction. Remember what we constructed here? We joined OA and ON. Those are the 2 that we joined, ON. Then we need to prove congruency. Where do we prove our congruency? It's vitally important that we should mention the triangle that I'll be using. In triangle OAM, and triangle ONM, This is where I'll be proving my congruency using one of those cases. Right, let's do this thing. Remember, the 2 triangles will be congruent if and only if 3 correspond, if 3 parts of, it's either 3 sides, or 2 sides and an angle, or 2 angles on the side, or 90 degrees hypotenuse on the side of one triangle are equal to the other one. They always go in pairs. Right. Let's do this thing. Let's start. If you like, you can unpack these 2. The other one is like this one. The other one is like this one. We've got O there. We've got what here? We've got M1. We've got O there. We've got M2. We've got A this side. We've got N this side. These are the 2 triangles that we have so far. Remember that we are given that this side is the same as this side. Those 2 are the same. It's given. So it is advisable that you always mention what you are given in this particular case. We want to prove that these 2 triangles are congruent. It can either use side, angle, side, or 90 degrees hypotenuse on the side. To prove the 2 are congruent, let's do this thing. Proof. Oh, let's mention the triangle. Oh, I've mentioned the triangle. Now let's do our proof. Right. Let's look at the first triangle. Let's call this our first triangle. We'll call that one our second triangle. Hence, I call it M1, M2. Now, we know that in this triangle, this side, AM is equals to NM. Why is this side the same as this side? It is given. It was given originally in the diagram. So the reason here is given. Remember, your reason is more important than the statement. If someone say AM is equals to NM, and the reason you write vertical opposite angles, then everything becomes wrong. So your reason is more important than your statement. Right, let's move on. So you've got, what is this? What is it that we got? It's the side. It can either be this, that, this, anything that has a side there. Any case of congruence that has a side can apply here because we've just checked one side. Number two, what else that we have there? Okay, let's move on. Let's look at OM. In these two triangles, there is OM in this triangle, which is the same distance as OM in the other triangle. Why are these two OMs the same? Why is this OM equals to OM? It is common. It is for both sides. This is a common side. So OM is equals to OM. So what is it that we have proved so far? What is this? What is AM and NM? These are sides. What is OM and OM? These are sides. So we've got two sides now. Right. You can't use this because this one uses one side and two angles. So that one already is fallen off because in this one, this is a side. This is also another side. Let's move on. So we've talked about OM and OM for both triangles. We've talked about our given, which was AM, which was the same as NM. Now let's look at the third one. This side, OA. OA is the same as ON on the other one. OA is the same as ON. OA is equals to ON. Why are these two the same? Why is this one equal to this one? What is the name of this distance? It is called the radius. What is the name of that distance? It is called the radius. And both of them are radii of the same circle. Therefore, these are the same, radii. Right. What is this? This is a side. What is this? It's also another side. What is this? It's also another side. Do you have a case of congruency that uses side, side, side? Yes, we do have the first one. Therefore, we can conclude that the two triangles are congruent. Therefore, triangle OAM, OAM, OAM is congruent to triangle ONM, ONM. So why are these two triangles, why am I saying these two triangles are congruent? Because they comply with one of the cases of congruency, which is side, side, and the side. So these two triangles are congruent. What do we mean by saying two triangles are congruent? It simply means that they are equal in all respects, in every way. Like the identical twins. They are coming from the same mother. They were born on the same date, same year, same father. So that's what we mean by congruent, equal in all respects. Now, what is this saying to us? When we say these two triangles are congruent, we simply means that their corresponding sides are the same, as well as their corresponding angles are the same. That is what we mean by congruent. This sign simply means congruent, means that they are equal in all respects. At the moment, we can see that this one is equal to this one. What else is equal? This side, we've just shown that this side is equal to this side. In this case, which was radii, what else is the same? This side is the same as this side. This was the common side. Now, not all the sides are the same when you talk about congruency. Only their corresponding angles should be the same. Now, let's look at the corresponding angles in this case. In other words, this angle will correspond with that angle. So those two angles will be equal. This one will correspond with this one. Do you see the third pair? The third pair also will be equal. The third pair will automatically be equal. Because this angle plus this angle plus this angle is 180. This angle plus this angle plus this angle is 180. Therefore, if this one is equal to that, and this one is equal to that, therefore the third pair will have to be equal. So simply means that this angle here is the same as this angle here. Where do we get that fact from? The fact that the two triangles are congruent. It simply implies that those angles, the corresponding angles are equal, as well as the corresponding sides are equal. What is it that we're saying here? We are saying here, angle M1 is equal to M2. Let's write that down. We are saying M1 is the same as angle M2. Why are these two the same? It's because we're taking the fact that the two triangles are congruent. So it's coming from congruency. Right. What is it that we're saying here? We're saying this angle is the same as this angle. But these are supplementary angles. We know that M1 plus M2 is equal to what? What is this angle plus that angle? It is equal to 180 degrees. Why? These are adjacent angles on a straight line. Adjacent angles on a straight line. So this angle plus that angle is equal to 180 degrees because they are adjacent angles on a straight line. But we've just said that M1 is the same as M2 because we got that from congruency. This angle is equal to this one. This one is equal to this one. That's what we've just said. M1 is equal to M2. Remember, we don't lose sight of what we want to prove. This is what we want to prove. We want to prove that M1, not M2, M1 is equal to 90 degrees according to our required to prove. Look here. We've just said M1 is the same as M2. Do I need M2 there? I don't need it. I've got M1 plus M2. Because we've got M1 there, and M2 is the same as M1, so where there's M2, I can substitute it with M1. So this is the same as M1 plus M1 is equal to 180. What is M1 plus M1? M1 plus M1 is going to give us 2 of that. 2M1 will equals to 180 degrees. If I'm looking just for 1 M1, remember all these are angles. If I want to remain with M1 here, I've got to divide by 2 on both sides. Or 2 times what will give me 180? It's 2 times 90 will give me 180. So this M1 is standing in the place of 90 degrees. Therefore, M1 is equals to 90 degrees. That's how I'll go about proving that this angle here or this angle here will be 90 degrees. In the same way, because these two are the same, if they ask for this one, you'll say it is 90 degrees or that one, because they'll give you the same thing. Thank you.